Hi, everyone, and welcome back um, to the next part of Part 4 Notes video key. We just finished with problem D here. Just a reminder, everything that this section is about angles that are formed on the edge of the circle. Angles that are formed on the edge of the circle, if we look at their angle measure and compare it to the arc they create, so like in problem D, that would be this squiggly line right here. Remember, angle measures always equal the arc divided by 2. And so that's what we're working on here. And let's go through F and E and F here. And for the purposes of this video, I'm going to erase everything on D just to give us a little bit cleaner view. So here we go. We're moving on to E. And so we need to find X. And so obviously that is this angle here. And this angle is on the edge of the circle, which is obviously important. And this angle goes to A and B. And so this arc in between A and B is the arc we are basing our angle off of. And remember, our angle is always half of what that arc is. But there's no number there. If there was a number, we'd just divide it by 2. And then we could set that equal to 2x, and we would solve for x. However, take a look at this. And I'm going to change colors to highlight it. The line A to B is what we call a diameter. Remember, diameter is just diameter. Is a line that has endpoints on the edge of the circle, so A and B, and it goes straight through the center. And what diameters do is they cut circles in half. And so if a circle is 360 degrees in total, half of a circle is 180 degrees, right? And so since this circle intersects with where our diameter starts and stops, this angle is opening up to 180 degrees of our circle. So then remember, that's our arc. Our arc has to be 180 because this diameter splits our circle into half. And so the angle we're working with, our 2x, always equals our arc divided by 2. So our 2x will equal 180 divided by 2. 180 is pretty easy to divide by 2, right? So 2x will equal 90. And then we need x by itself, so the last thing we'll do is divide both sides by 2, and we get x equals 45. Right? Perfect. And so recognizing that diameter in this problem was really the key for that one. All right, and so let's move on to F. All right, now, a lot of things here. We need to find out what X is. But if we look at like B and C, these are angles on the edge of the circle. And so their angles will be half of, what the arc is. And so angle B opens up to arc AC. And that would be, so 4x is going to be half of what that arc is. But we don't have any numbers there. And so I don't think that can help us. So I'm going to erase that. Looking at the 6x, that's an angle on the circle. It opens up to the arc between A and B. So 6x will be half that arc. But again, we don't have any numbers there. So I don't think that'll help us. And so what I want you to see here is A is also an angle on the edge of the circle. And A opens up to where C and B are on the edge. And so the arc that angle A creates is this big one between C and B. And something you got to recognize, just like last problem, was if we connect C and B directly, it goes through that center, right? And so C and B, once again, is a diameter. And diameters then cut our circle in half. And so the arc we're actually working with on this half of the circle has to be 180 degrees. Since again, that diameter is cutting it in half, and that diameter starts and stops where our arc starts and stops. And so angle A, the one we're missing in this triangle, is going to be half of the arc, right? So it's half of 180, which means angle A has to be 90. And that's huge because now I'm going to change the color once again, and I'm going to ignore the circle. And I'm just going to highlight this shape inside the orange. That's a triangle. And we now know all three angles of the triangle, 4x, 6x, and 90. And we should know very much so by now that all three angles in a triangle always add to 180. And so again, let's ignore the circle now, and we'll just work with that triangle. And we want to add all three angles together, 6x plus 4x plus 90, right? And when we add three angles of a triangle together, it always equals 180 degrees. And so now we can solve this equation for x. And it's not even too bad to do that. And so let's combine our like terms. 4x and 6x is going to give us 10x. Our 90 is still there, still equals 180. We'll subtract 90 from both sides. We get 10x equals 90. And then we'll divide both sides by 10, leaving us with x equals 9 as our final answer. So just a reminder and just kind of a shout out, don't forget any of the past stuff, right? Triangles, and we've already talked about linear pairs, vertical angles, those kind of things. That's one of the tricks with geometry. Old skills always continue to apply in new situations. And so we got to continue to maintain our understanding from some of these old chapters and units as well. And so that's how you work through problem F. Now let's move on to a fairly simple theorem, but a theorem we need to talk about nonetheless. So let's say we have two inscribed angles of a circle. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. And that's the congruent symbol. Remember, congruent as a word is like this. And remember, congruent essentially means equal, right? They're the same. And so here's like a picture. Let's say this is one angle. And so let's call this part A, and let's call this part B. And we'll call this part over here C. So angle C is obviously on the edge of the circle, and it creates that arc from A to B, right? Well, let's add a new angle. Let's say I have a D down here. Let's say D opens up to A and to B. And so angle D intersects at A and intersects at B as well. And so angle D opens up to the exact same arc. They intercept the exact same arc. Well, when that happens, we would then know that angle C equals angle D, right? Because whatever number our arc is, angle C is going to be half that number, and angle D is going to be half that same number as well, which means those two angles are equal. And so what we really don't even need is we don't even need the arc. It doesn't matter because we can just set each of the angle things equal to each other. And I want to show you how that works in these examples. So where our X is, I'm going to make that green real quick. That angle opens up to just that little arc there, right? Just the little arc right here. And then the 2x minus 7 angle opens up to that exact same little arc, just that little arc there. And so again, that's the same arc. And when they open up to the same arc, those angles are equal to each other. So we can just take x and set it equal to 2x minus 7. And we just got to solve this and we'll get x. So we'll subtract 2x from both sides. And that's like a 1x minus a 2x. So that leaves us with a negative x on the left. And that equals negative 7. Now, I won't do this all the time, but that's like negative 1x equals negative 7. So we can divide by negative 1 at this point, and that'll tell us that x equals positive 7. And that's our answer. Now, in B, right, same exact idea. Try to go through it slow. The 2x plus 11, here's that angle on the edge of the circle, and it opens into this arc right here. Perfect. But then if we look at the 4x minus 3, right, that arc is on the edge of the circle, or that angle is on the edge of the circle, and it opens up to that exact same arc that the red angle opened up to. So again, that's the same arc that each of these angles are intercepting, and so the two angles must equal each other. 2x plus 11 equals 4x minus 3. So I'm going to subtract 2x from both sides. Get 11 equals 2x minus 3. I'm going to add 3 to both sides. So 11 plus 3 is 14. That still equals 2x. And then we'll divide both sides by 2. And we get that x is 7. So same exact answer as the other problem. Obviously different expressions. But we're doing the same thing. When your two angles that are on the edge of the circle open up to the same arc, those angles must be equal to each other. So we set them equal to each other and solve for x. All right, very last thing of this part of the notes, theorem, a quadrilateral. Remember, a quadrilateral is a four-sided shape. So a quadrilateral can be inscribed, which means all four angles are on the edge of the circle. So a quadrilateral can be inscribed in a circle if and only if opposite angles are supplementary. And supplementary means add to 180 degrees. And so if we draw a random four-sided shape in here, go straight down, right? A random four-sided shape where every single angle or corner of this shape is on, right? On the edge of the circle. Then this happens. And I'm going to call these points D, E, F, and G. So D, E, F, and G. And basically the idea is opposite angles, so angles that are across from each other. So that would be D and F. That has to equal 180. And then also E and G has to equal 180. And so we can just say like measure of angle D plus measure of angle F equals 180 because they are across from each other. And then same with E and G. Measure of angle E plus measure of angle G equals 180. And so if we ever see four-sided shapes, like in the example below, we want to look across the angles and those two, across the shape, and those two angles that are across from each other should equal 180. And so let's do that. So if we want to do the x one, the 2x and the 100 are across from each other. So 2x plus 100 should equal 180. And we'll subtract 100. 2x equals 80. And we'll divide by 2. And we get that x equals 4. And then the same property applies for y. So y is across from 87. So y plus 87 has to equal 180. Just the two angles that are across from each other, if we add them together, they equal 180 if there's a four-sided shape inside of our circle. So I'm going to subtract 87 from both sides here, and I get that y equals 93 degrees. Perfect. All right, last piece. Let's start with x. So 3x and the box are across from each other. Remember, the box is 90 degrees. And so to find x, we'll do 3x. And remember, we're adding the angles. So 3x plus 90. And together, they equal 180. Subtract 90 from both sides. 3x equals 90. And divide by 3. X equals 30. Perfect. And then the last one, the 2y minus 3 and the y plus 5 are across from each other. Remember, we want to add them together. So we'll go 2y minus 3 plus y plus 5, and together they equal 180. So we'll combine like terms. 2y, 1y gives us 3y, minus 3 and plus 5 gives us a plus 2, and that equals 180. Subtract 2 from both sides. 3y equals 178. And then divide both sides by 3, and we get that y equals 59.3 repeated. Perfect. And that's it for part 4. And so let's move on to the part 4 worksheet. Let's continue to review this, practice these things, reach out if we have any questions. The big key of the day was that anytime there's an angle on the edge of the circle, it equals half of the arc it creates. And so there's a variety of ways we can use that. Sometimes we just divide by 2. Other times, if we're working backwards, we have to multiply by 2. If we have two angles that open up to the same arc, those angles are just equal. And if we have a four-sided shape in there, opposite angles combine, meaning add together, to equal 180 degrees. All right. Thank you very much for your time. Have a great day.